Good morning. It is Monday, April 27th. Today we will rotate objects in 3 dimensions by reflecting in 2 dimensions and connecting the image and the pre-image with curves. The notes are pretty much exactly what the aim says. We're reflecting the shape in 2 dimensions and connecting the images with curves. And it says it's almost always a cylinder or a cone. The reason for that, since we're always connecting it with curves, it has to be a 3-dimensional shape that's curved. A cylinder is curved, a cone is curved, a rectangular prism or a cube, since it's boxy, you can't end up with because it doesn't have any curves. So I'll show you exactly how to do this. Once you get the hang of it, it's pretty simple. Which object is formed when right triangle RST shown below is rotated around leg RS? So if I want to rotate this triangle around this leg, I'm going to start by reflecting it in 2 dimensions. If I want to reflect over this line, well, T is going to go here. And then I throw it in. That's what we did earlier in the year. That's a reflection. And now I'm going to connect it with curves, since it's spinning in a circular motion. What 3-dimensional shape is that? That's a cone. So I'm reflecting in 2 dimensions, and I'm just connecting the original and the image with curves, because if I'm rotating something in 3 dimensions, it's going in a circular motion. Basically, this triangle is spinning around this leg. If the rectangle below is continuously rotated about side W, which solid figure is formed? So I'm rotating it around side W. So it's like a flag here that I'm spinning around this flagpole. So I'm going to reflect it in 2 dimensions, and then I'm going to connect the original and the image with curves. What shape is that? Well, that looks like a hockey puck, which is a cylinder. It's kind of a short cylinder, but a cylinder nonetheless. I want you to try 3 and 4 on your own right now. I'm going to give you about a minute or so to try 3 and 4 on your own. Okay, 3. If you rotated it about line M, so this is line M here, I reflect in 2 dimensions, I connect the original and the image with curves, cylinder. I reflect in 2 dimensions, I connect with curves, cone. Hopefully this is making sense. It's pretty simple as long as you follow the procedure. Reflect it in 2 dimensions, connect it with curves. Number 5, it wants you to take this quarter circle and rotate it about the y-axis. So I'm going to let you try this on your own. I'm going to give you about 30 seconds. Reflect it over the y-axis in 2 dimensions, and then connect it with curves. I'll give you about 30 seconds. Okay. To reflect it in the y, it's going to look something like that. Then I connect the original and the image with curves. Looks like a cereal bowl. The hemisphere. Hemisphere, again, is half of a sphere. Now we're kind of doing a little bit of a word problem with it. Which 3-dimensional figure will result when a rectangle 6 inches long and 5 inches wide? So let's draw this rectangle. It's 6 inches long, it's 5 inches wide, is continuously rotated about the longer side. So the longer side, is the longer side 5 or 6? Well, if you can't answer that, I can't really do much for you. 6 is longer than 5. So let's just do a different color here. So if I'm rotating it around the longer side, I reflect it in 2 dimensions. I connect it with curves. So first of all, do I have a rectangular prism or do I have a cylinder? This is a cylinder, so it can't be choices 1 or 2. With a radius of 5 and a height of 6, or a radius of 6 and a height of 5. Well, my radius is right here. My height is right here. My radius is 5. My height is 6. Notice that the cylinder is on its side. Radius of 5, height of 6. There you go. And that's why it's important to not just know that it's going to be a cylinder. You have to know what this cylinder is going to look like by, again, reflecting in 2 dimensions and connecting with curves. So I want to skip ahead to number 10. In the diagram below, right triangle ABC has legs whose lengths are 4 and 6. What is the volume of the 3-dimensional object formed by continuously rotating the right triangle about AB? So I'm rotating it about AB. So in order to find the volume of this object, I first have to find this object. So I'm going to reflect it in 2 dimensions and connect it with curves. What shape is that? That's a cone. So notice, it doesn't say cone anywhere in the problem. We need to understand that when I reflect this triangle, or sorry, when I continuously rotate this triangle, I end up with a cone. So now you can go to your reference sheet. Hopefully at this point you have it memorized. If not, it's all good. It's on the reference sheet. Cone is 1/3 pi r squared h. V equals 1/3 pi. What's the radius of this cone? 4. You're not cutting it in half because it's the radius, not the diameter. It only goes from the center to the end point. The height is 6. Am I typing pi in or not? Since there are pi's in the answers, no, you're not typing pi in. So I'm just going to pull up my calculator. I'm going to type in 1/3. Again, I'm not going to type pi in since the answers all have pi in them. 4 squared times 6, 32. So V equals 32 pi. Choice 1's the answer. And that's it. So to find a 3-dimensional shape, when you're continuously rotating, you're going to reflect in 2 dimensions, connect with curves, and then from there, if it asks you to find the volume, you use your volume formula after you do the 3-dimensional rotation, just like we've been doing. So let's try one more, and then I'm going to let you finish on your own. This one's got a little twist, so we're going to take a look at number 12. If it has a little twist, we'll do it partially together. In a diagram, a right triangle ABC shown below. AB is 14, AC is 9. What is the volume of the 3-dimensional object formed when the triangle is continually rotated about BC? So I'm going to give you 15 seconds. Start by rotating it about side BC. Okay, that's enough time. Reflect it in 2 dimensions. Connect it with curves. That's a cone. So again, a cone is on your reference sheet, 1/3 pi r squared h. So the radius is 9. The height, well, I don't have the height. I have the slant height. Do you remember what to do when they give you the slant height? I do. If they give you the slant height, you're going to have to find the height using Pythagorean theorem. So I'll give you about a minute or so to try and do Pythagorean theorem on your own. Again, we're looking to find the height. The legs are 9 and X. That's 115. Square root. I'm just going to leave it as radical 115 for now. You could make it into a decimal, doesn't matter. So now I'm going to go to my calculator, and I've got 1/3. It says to the nearest tenth, so I'm typing pi in. Pi 9 squared, radical 115. And to the nearest tenth, that is 909.6. And that would be your answer. So again, for this one, I had to first start by doing the 3D rotations by reflecting in 2 dimensions and connecting with curves. Once I had the cone, I know my cone formula is right here. I had to use Pythagorean theorem to come up with the height of that cone, and then from there I substituted in. So to do 3D rotations, we're going to reflect in 2 dimensions and connect the image and the pre-image with curves. Usually you're ending up with a cylinder or a cone. Since it has to be a curved shape, it can't be a rectangular prism, it can't be a cube, it can't be a triangular prism. It could be a sphere or a hemisphere as well, but it has to be something that's curved. And if they ask you to find the volume of a shape, well, you first do the 3D rotation, and then you find the volume, just like we've been doing all unit. Your classwork/homework is to finish 3D rotations. Again, I'm going to give you 2 days to do this, even though it's a 1-day lesson. And then you're going to have a quiz due Tuesday on this. Again, any questions, reach out to me on Remind, and I hope everyone has a great day.